Imagine inventing the exact technology that, eventually pulls the entire world out of a massive global pandemic.
Like the literal silver bullet.
Exactly. Something that saves millions of lives and, frankly, just single-handedly stabilizes the global economy.
It's a pretty good day at the office.
You would think so, right? But now imagine that your reward for dedicating your entire life to this breakthrough is getting officially demoted.
Oh, wow.
Yeah, being repeatedly mocked by your peers and then having your own university just sell the rights to your life's work to, like, a lab supply salesman right out from under you.
It sounds like fiction, honestly.
It really does. But welcome to the Deep Dive. Our mission today is to explore the, well, truly staggering and deeply frustrating life of Hungarian-American biochemist Katalin Karikó.
And ultimately triumphant life, I should add.
Oh, absolutely triumphant. But, if you've ever had a manager take credit for your work, or if you've ever been told your ideas are just too radical, you really need to hear this.
Yeah, this isn't just some sterile timeline of, scientific achievements.
Not at all. We are unpacking a gripping biography here. It's about resilience, corporate betrayals, vicious academic feuds, and eventually, ultimate vindication.
We're going to break down how one woman's incredibly stubborn belief in mRNA technology defied and then literally rescued the entire scientific establishment.
So setting the stage here, I think it's crucial to just reframe how we think about innovation.
Yeah, because we all throw around the term mRNA today like it's always been this obvious golden child of modern medicine.
Right. It's a household word now. Everybody knows it.
Exactly. But for decades, literally the bulk of Karikó's career working on mRNA was considered a total career-killing scientific dead end.
A dead end. Like, people would tell you to stay away from it.
Oh, the scientific consensus wasn't just ambivalent, it was actively hostile toward her work.
Which is wild to think about now.
It really is. And understanding her journey, it kind of changes how we view progress. It shatters this comforting illusion we have that science is just this orderly, logical progression.
Right, where the best ideas are just immediately recognized and everybody cheers and gives you funding.
Exactly. When in reality, it is so often this brutal, exhausting war of attrition against the status quo.
So let's look at where that kind of attrition tolerance actually comes from. Because you don't just wake up one day with the ability to withstand, decades of institutional rejection.
No, you definitely have to be forged in a very specific type of fire for that.
Right. So to understand the scientist, we have to look at the crucible. We are starting in Hungary in the mid-20th century.
Okay, setting the scene.
Katalin Karikó was born in 1955 in Szolnok, and she grew up in a town called Kisusalas. And, the environment she is raised in is so fundamentally detached from the ivory towers of Ivy League research.
It's basically a different universe.
It almost sounds like a different century, honestly. We are talking about a small home with literally no running water, no refrigerator, and no television.
The contrast there between her material environment and, well, the intellectual foundation she was building is just profound.
Yeah, her mother was a bookkeeper. Her father, Janos, was a butcher.
But there is this much heavier historical reality shaping their lives, too, based on the historical record from our sources.
Right, the 1956 Hungarian revolt.
Exactly. Her father was actually punished for participating in that revolt against Soviet policies.
Oh, wow. So from the very beginning, she is dealing with that shadow.
Yeah, from her earliest cognitive moments, she is embedded in an environment where the state is this oppressive, watchful entity.
It's always there.
Always. And standing up to massive systemic power, it carries a very real, very physical cost. You learn very quickly that the world is not fair and no one is going to hand you anything.
And yet, despite that incredibly heavy atmosphere, she just thrives intellectually. By the 8th grade, she is placing 3rd in the entire country in a national biology competition.
Which is just incredible.
A retrospective by the University of Szeged actually noted that her early passion for chemistry and biology was intensely nurtured through these rigorous academic competitions.
It makes sense. It's an outlet.
Right. I just think about this kid growing up in a house without a fridge, stepping outside to observe the natural world of the Hungarian plains, and just independently deciding, she needs to figure out the mechanisms of life.
It builds a very specific type of cognitive architecture. you know?
How do you mean?
Well, when you learn to analyze complex biological systems without the crutch of high-end, comfortable infrastructure, when you are relying purely on your own observation, deduction, and frankly, fierce competition, you develop a certain grittiness.
Like an intellectual callus.
Exactly, a callousing. She wasn't handed state-of-the-art lab equipment. She had to constantly observe and prove her worth. That resilience literally becomes the defining characteristic of her entire methodology later on.
And she carries that intense drive right through her formal education. She earns her Bachelor of Science in Biology in 1978, and then her PhD in Biochemistry in 1982.
Both from the University of Szeged, right?
Yes, exactly. And then she starts working at the Biological Research Center, the BRC, in Hungary.
But this is where her trajectory hits a really incredibly dark and complicated piece of Cold War history.
Yeah, this part is intense. The records show that between 1978 and 1985, while she was researching at the BRC, Katalin Karikó was listed as an intelligence asset by the Communist Hungarian secret police.
And the revelation of that documentation caused a pretty significant media stir when it eventually came to light.
I mean, I have to jump in here because if I'm listening to this, my immediate reaction is going to be absolute shock.
Oh, for sure. It sounds crazy.
Like, wait, are you telling me the pioneer of the COVID vaccine, the person who arguably saved the modern global economy, was a communist spy?
Right. And it's vital we parse exactly what the sources and the historical context actually tell us here. We have to separate the sensationalism from the reality of Soviet-era coercion.
Okay, so what is the reality?
Yes, the documentation shows her name was listed. However, Karikó has explicitly stated that she was blackmailed into this position.
Blackmail.
Yes. Think about the leverage they had over her. She was a young, ambitious scientist trying to build a career in a state that completely controlled every single aspect of employment.
So if they say, sign this, you don't really have a choice if you want to work.
Exactly. The secret police leveraged her vulnerability. They threatened severe repercussions on her career, but far more devastatingly, they threatened reprisals against her father.
Oh, right. Because of the 1956 revolt.
Precisely. Her father was already a known target with a massive target on his back.
So it's literal extortion. The state apparatus is basically holding your father's physical safety hostage just to force your name onto a registry.
That is exactly what it was. And she has maintained unequivocally that she never actually provided them with any information.
She never acted as an agent.
Never. The internal logic of the communist system in Eastern Europe during that era, it relied heavily on building this massive, terrifying apparatus of forced compliance.
It's making people paranoid.
Right. Simply getting citizens on a list, making them feel watched and compromised, was a primary method of psychological control.
It's just a suffocating way to live. I mean, you are a brilliant scientist, you're a young mother, and your own government is holding a metaphorical gun to your family's head.
It's unimaginable pressure.
And the awful irony is, even enduring that coercion doesn't actually save her position.
Mm-hmm.
Because in 1985, the broader economic failures of the state start to trickle down, and her lab at the BRC simply loses its funding.
So she's left with nothing.
Yeah, she is effectively out of a job in a country where she is being actively monitored and extorted.
But at that point, the calculus changes entirely. She has to look outward. But seeking work at foreign institutions from behind the Iron Curtain was, it was an incredibly labyrinthine and dangerous process.
But she manages to secure a lifeline. She gets a firm offer for a research position in the United States from a scientist named Robert J. Sudolnik at Temple University in Philadelphia.
But getting the offer is only half the battle. Actually getting out is another thing entirely.
Right. And this is where we get to the legendary black market teddy bear story.
I love this story.
It's wild. So to leave the country with her husband, Bella Francia, and their 2-year-old daughter, Susan, they obviously need capital to start a new life.
Sure, you can't just show up with nothing.
Right. But they are living in a heavily restricted, monitored communist economy. They can't just, wire funds to an American bank.
No, international banking wasn't exactly an option for them.
So they sell their car on the black market for £900.
Which introduces an immediate, terrifying logistical problem.
The border guards.
Exactly. Moving foreign currency out of the country was strictly forbidden. If the guards caught them with that cash, the consequences would have been catastrophic.
Especially given her father's political history and her own complicated coerced status with the state police.
It would have been the end of the line.
So they resort to absolute desperation. They take their 2-year-old daughter's teddy bear, cut it open, stuff the 900 pounds inside the stuffing, and literally sew it back up.
Just incredible.
They smuggle their entire net worth out of the Soviet bloc inside a toddler's plush toy.
Think about the sheer tension of that border crossing.
I would be sweating bullets.
Right. You are betting your physical freedom, your family's future, and your entire financial existence on a precarious, low-paying academic job halfway across the world.
It is the ultimate manifestation of risk tolerance. You don't make a move like that unless you possess a profound, almost unshakable belief in your own ability to succeed once you get to the other side.
Absolutely. And as a brilliant little extrapolation from our sources, that risk clearly paid dividends across generations.
Oh, this is my favorite fun fact.
It's so good. That 2-year-old girl clutching the money-stuffed teddy bear, Susan Francia, would grow up in the United States to become a 2-time Olympic gold medalist rower.
That is just unbelievable. Excellence and an absolute refusal to quit is clearly just baked into that family's DNA.
It really seems that way.
But arriving in America doesn't mean it's a magical happily ever after. She trades the overt, state-sponsored oppression of a communist regime for the covert, deeply systemic toxicity of the American academic machine.
Yeah, the academic trenches are brutal in their own way.
Right. So she starts her postdoctoral fellowship at Temple University between 1985 and 1988.
Right. She is working in pseudouridine lab, and the work itself is highly significant. They are running clinical trials, treating patients who have AIDS, hematologic diseases, and chronic fatigue syndrome using double-stranded RNA or dsRNA.
Now, I want to pause on the science for a second because we need to map out why this matters.
Good idea.
Treating these severe immunodeficiencies with dsRNA was considered cutting edge at the time. The scientific community generally knew that interferons produced antiviral and anti-tumor effects, but the actual molecular mechanism, like how dsRNA induced the body to create those interferons, was just a black box.
Right. It was a total mystery.
Right.
And Karikó is plunging right into the deep end of complex immunology here. She's doing foundational work.
But the friction comes when she tries to advance her career.
As it often does in academia.
By 1988, she gets a highly prestigious opportunity to accept a job at Johns Hopkins University.
A huge step up.
Massive. The misstep she makes, at least in the highly political, feudal microcosm of the lab, is that she doesn't inform her boss, Suhadolnik, about her intention to leave before formally accepting the Hopkins offer.
Oh, boy.
Wait, I have to stop you there. We culturally think of academia as this enlightened meritocracy, right? A place of pure intellectual pursuit.
People certainly like to think that.
But the way Suhadolnik reacts, according to Gregory Zuckerman's 2021 book, A Shot to Save the World, is viciously retaliatory. He doesn't just write a bad reference.
No, he goes scorched earth.
He actively weaponizes her immigration status to destroy her life.
It exposes a massive vulnerability in the academic visa system. Lab advisors, principal investigators, they hold an immense, largely unchecked amount of power over international researchers.
Because your visa is tied to them.
Exactly. Your J-1 or H-1B visa is inherently tied to your specific employment. If you lose the job, you lose your legal right to remain in the country.
And Suhadolnik actually threatened to have her deported.
He went further than a threat. He actually called U.S. immigration authorities and falsely reported her, claiming she was residing in the United States illegally.
He used the federal government to try and ruin her life simply because she sought a better job.
It's terrifying.
And while she is suddenly forced to fight this extradition order, literally fighting to stay in the country, she just risks everything to escape to the clock runs out. Johns Hopkins withdraws the job offer.
The collateral damage is total. And Suhadolnik continues his campaign. He actively badmouths her across the tightly knit academic community, effectively blackballing her.
He made it nearly impossible for her to find a new position anywhere. The level of vindictiveness is just staggering to me.
It really is.
But what genuinely blows my mind is how Karikó views this event in hindsight.
This part is fascinating.
When this horrific abuse of power became highly public in 2021 through Zuckerman's book, Karikó confirmed the events happened exactly as described. But then, astonishingly, she publicly emphasized her gratitude to Suhadolnik.
Wait, really? She thanked him?
Yes. She stated she was always grateful to him for sending her the initial paperwork in 1985 that allowed her to leave Hungary and for the initial opportunity in his lab. She even recounted how years later, when she gave a lecture at Temple, she thanked him for the science he taught her.
That requires a level of compartmentalization that is almost superhuman.
It's wild, right?
Yeah, I mean, she was able to decouple the objective scientific knowledge she extracted from the lab from the deep personal trauma inflicted by the man running it.
That's a great way to put it.
It indicates a laser-like, almost obsessive focus on the work itself. The science was literally the only thing that mattered to her.
Which is exactly what keeps her moving forward. After being blackballed, she manages to find a researcher at Bethesda Naval Hospital who, serendipitously, had his own history of conflict with pseudouridine.
The enemy of my enemy is my friend.
Exactly. That shared trauma gets her a stopgap position working with signal protein interferons from 1988 to 1989. And then finally, in 1989, she lands a job at the University of Pennsylvania.
The University of Pennsylvania. This is the pivotal arena. UPenn becomes the site of her greatest world-changing scientific discoveries, and simultaneously the site of her deepest, most systemic professional humiliations.
Let's talk about the dark age of mRNA. She arrives at UPenn to work with a cardiologist named Elliot Barnathan, and in 1990, holding the title of adjunct professor, she submits her first grant application proposing mRNA-based gene therapy.
And to understand why that grant was completely doomed, we have to look at the scientific climate of the 1990s.
That wasn't friendly, I'm guessing.
Not at all. Today, mRNA is ubiquitous, but in 1990, it was universally considered a catastrophic dead end. The entire scientific community, university researchers, biotech firms, massive pharmaceutical conglomerates had essentially abandoned it.
We need to go a layer deeper here because I don't want to rely on basic analogies. If you're listening to this, you likely know the basic biology, right?
DNA is the permanent archive in the nucleus, and mRNA is the temporary transcript sent into the cytoplasm to instruct the ribosomes on which proteins to synthesize.
Right, and the theoretical appeal is obvious. If you can synthesize your own mRNA and deliver it to a patient's cells, you basically turn the human body into its own pharmaceutical factory.
You can instruct the body to create antibodies, fix genetic defects, or target tumors.
The theory is flawless.
The theory is flawless. The in vivo reality, however, was an absolute nightmare.
What went wrong?
Well, the critical barrier in the 1990s wasn't understanding what mRNA did. It was its extreme volatility. Messenger RNA is inherently unstable. Our bodies are flooded with RNases enzymes specifically designed to seek out and degrade stray RNA.
Because stray RNA usually means trouble.
Exactly. If you inject naked synthetic mRNA into an animal, it gets chewed up and destroyed before it even reaches a cell.
But even if it survived the bloodstream, there was a secondary, far more dangerous problem, right?
Oh, a much bigger problem. The immune cascade. When researchers injected synthetic mRNA, the body didn't just ignore it, it violently attacked it.
It saw it as an invader.
Right. The innate immune system has incredibly sophisticated sensors, specifically endosomal toll-like receptors, that evolved over millions of years to detect foreign RNA. Because foreign RNA usually means a viral infection.
So when they detected the synthetic mRNA, they triggered a massive, highly toxic inflammatory response. So you aren't just failing to deliver the message, you are actively poisoning the patient.
Yeah, it's terrible.
You're basically sending a delicate paper airplane directly into a cellular hurricane. The mRNA is shredded, and the body goes into toxic shock. So naturally, everyone just gave up.
And this is where we see the structural flaw in how institutional science is funded. Grant committees at the National Institutes of Health or massive university funding bodies, they do not reward kamikaze missions.
They want a sure thing.
Exactly. They operate on highly risk-averse algorithms. They want incremental progress on proven safe theories. Karikó was asking for money to pursue a high-risk, paradigm-shifting, repeatedly failing technology.
And she was actively punished for it. She applied for grant after grant, and she was summarily rejected every single time.
And in academia, your worth is entirely tethered to your ability to bring in grant money.
Which brings us to 1995. Because she couldn't secure funding, UPenn decided she was a liability. They officially demoted her. They completely stripped her of her path to a full professorship.
A demotion of that magnitude is basically the academic equivalent of a polite execution. The university is essentially telling you, you are no longer faculty material, pack your bags and find another career.
But her response just defies all professional logic. She doesn't leave.
She stays.
She accepts the demotion. She accepts the lower rank, the lower salary, the complete lack of prestige, purely to maintain physical access to a laboratory bench so she can keep running her mRNA experiments.
That is a staggering display of stubbornness.
It really is. Her champion, Elliot Barnathan, leaves UPenn in 1997. So she is left utterly isolated, a researcher without a lab. She is saved only by a neurosurgeon named David Langer, who uses his own discretionary funds to keep her minimally employed.
She is effectively a ghost in the department at that point. She has no assistance, no dedicated funding, no status. She is forced to do all her own grunt work.
But ironically, it is exactly this lack of resources, being forced to use the communal department machinery, that sets up the most important chance encounter in modern medical history.
The 1997 copy machine meet cute.
Yes. Karikó is literally standing at a communal photocopier, copying dense scientific journal articles, when she strikes up a conversation with a guy named Drew Weissman.
And Drew Weissman was a newly arrived professor of immunology at UPenn. And unlike Karikó, Weissman had the golden ticket. He had significant institutional funding.
The Holy Grail.
Right. He was running a lab trying to develop a vaccine for HIV.
The synergy here is almost too perfect. Karikó has this obsessive, granular understanding of RNA biochemistry, but she lacks the deep immunological background to figure out exactly why the immune system is shredding her synthetic molecules. Plus, she has absolutely no money.
And Weissman has the immunology expertise, the specific knowledge of cellular dendritic cells, the lab space, and the budget.
It's the perfect match.
Elliot Barnathan had previously noted Karikó's unique intellectual appetite. She didn't just read within her narrow subfield. She read voraciously across entirely disparate scientific disciplines.
Connecting the dots.
Exactly. She tracked the latest obscure papers. She had this remarkable ability to synthesize seemingly unrelated data points. When she teamed up with Weissman, they began to systematically dismantle the mRNA inflammation problem, variable by variable.
And it took them years of agonizing trial and error. As Weissman later said, we had to fight the entire way. But in 2005, they finally published the landmark study that cracks the code.
So how did they do it?
Well, Karikó was running control experiments using different variations of RNA. She noticed an anomaly. Transfer RNA, or tRNA, which is abundant and naturally occurring in our own cells, did not trigger any immune reaction when introduced to their dendritic cell cultures.
This is the critical inflection point. Synthetic mRNA caused a toxic inflammatory cascade. Natural tRNA did not. The obvious deduction is that there is a structural chemical difference between the two molecules that the immune system is recognizing.
Right. We know RNA is composed of 4 primary nucleoside building blocks: adenine, cytosine, guanine, and uridine.
The letters of the genetic code.
Exactly. Through meticulous isolation, Karikó and Weissman discovered that the cellular security alarms, the toll-like receptors, specifically TLR7 and TLR8, were hyperfixated on the uridine and the synthetic mRNA. Unmodified uridine was the glaring red flag that triggered the attack.
So they looked closely at the tRNA, and they realized that in natural tRNA, the uridine often undergoes a post-transcriptional modification. It changes its chemical shape slightly into something called pseudouridine.
I know we want to avoid overly simple analogies, but the sources specifically highlight this concept, and I just love the visualization of putting a fake mustache on the molecule.
It's a great image.
You take this synthetic mRNA instruction manual, and you chemically swap out the standard uridine for pseudouridine. You alter the stereochemistry just enough.
And suddenly, when this modified mRNA enters the cell, the toll-like receptors sweep over it and register nothing.
The disguise works flawlessly.
It's amazing. The mRNA slips past the innate immune security, remains completely undetected, and delivers its instructions to the ribosomes. No inflammation, no toxic cascade. The protein gets built.
It is a breathtakingly elegant biochemical solution. By suppressing the RNA recognition by the toll-like receptors, they rendered the synthetic mRNA non-immunogenic. They solved the fundamental problem that had paralyzed the entire field for 15 years.
They essentially hold in their hands the key to revolutionizing modern medicine.
So they write up their findings, submit the paper, and prepare for the scientific establishment to just throw a parade in their honor. And what does the establishment do?
They reject it outright.
It's infuriating.
It really is. They submit this world-changing discovery to Nature and Science, arguably the two most prestigious scientific journals on the planet, and the reviewers essentially say, "No thanks, this is an incremental novelty. Not interesting enough."
Not interesting enough. It's mind-blowing.
It highlights the extreme inertia of scientific consensus. If a field has been labeled a dead end for a decade, peer reviewers develop an inherent bias against any data claiming otherwise.
They just can't see past their own assumptions.
Right. They eventually managed to get the paper published in a specialized journal called Immunity in August 2005. It was a massive victory, but it went largely unnoticed by the wider community at first.
And the reality was, solving the inflammation problem was only half the battle. They had the perfectly disguised instruction manual, but you can't just inject naked modified mRNA into a patient's arm.
Because the enzymes in the bloodstream will still degrade it before it physically enters the target cells.
Right. They needed a sophisticated delivery vehicle.
You have the protected cargo, but you need an armored transport to navigate the hostile environment of the bloodstream and successfully breach the cellular membrane.
This brings us to the development of lipid nanoparticles, or LNPs, and a chapter of corporate heartbreak that is genuinely hard to stomach.
Oh, this part is rough.
Karikó and Weissman realized they needed to encapsulate the mRNA inside microscopic fat droplets.
Lipid nanoparticles are marvels of biophysical engineering. You encapsulate the fragile mRNA inside a dense protective sphere of specially designed lipids.
Looks like a fat bubble.
Exactly. These lipids protect the RNA from degradation in the blood. But more importantly, because human cell membranes are also primarily composed of a lipid bilayer, the LNP can smoothly fuse with the target cell, essentially melting into the membrane and depositing the mRNA payload directly into the cytoplasm.
But mixing the RNA and the lipids at a microscopic scale is incredibly difficult.
Very difficult.
So in 2006, Karikó reached out to a biochemist named Ian McLaughlin to collaborate on the highly complex mixing processes required to establish formulated lipid nanoparticles.
They had to perfect the ratios of cationic lipids and pegylated lipids to ensure stability and endosomal escape, and they succeeded. They proved the delivery system worked in animal models. The technology was finally complete and viable.
Naturally, knowing the immense value of what they had built, Karikó and Weissman sought to protect their intellectual property. In 2006, they founded a small company called RNRX with the express purpose of patenting and developing their modified nucleoside technology.
And this is where the bureaucracy of the American university system rears its head in the ugliest possible way.
UPenn strikes again.
Yeah. UPenn, like most research universities, operates under specific intellectual property frameworks. The researchers invent the technology, but the university retains the overarching ownership of the patents.
It's standard practice under laws like the Bayh-Dole Act. The university's tech transfer office is legally permitted to license those patents to outside entities to commercialize the research.
But consider how they did it. UPenn takes the exclusive intellectual property license for Karikó and Weissman's modified mRNA technology and sells it.
Just sells it.
They sell it to a lab supply vendor named Gary Dahl, who headed a company that eventually became CellScript.
They had the legal right to do it, but the ethical blindness of the decision is just staggering.
Wait, I really want you to think about the audacity of this institution. UPenn is the exact same school that actively discouraged her research for over a decade.
They underfunded her.
They humiliated her. They officially stripped her of her tenure track and demoted her because they deemed her work a useless waste of lab space.
And the second that useless work yields a viable patented technology, the university turns around and sells her life's work to a third party.
And the timing of the sale is absolutely brutal.
Oh, it gets worse.
Because just weeks after UPenn finalized the license sale to Gary Dahl, a massive venture capital firm called Flagship Pioneering contacted Karikó. Flagship was backing a new, highly ambitious biotech startup called Moderna.
Moderna.
Right. They recognized the power of the modified mRNA, and they wanted to license her patent.
I cannot imagine the sheer heartbreak of that phone call. Karikó has to get on the line with a massive VC firm that finally, after 30 years, sees the value of her work, and she has to tell them, I'm sorry, I don't own it. The university sold it to someone else.
It is a devastating twist, and the psychological hits just keep coming.
Fast forward a few years to early 2013. Karikó hears the news that Moderna, the exact company that tried to license her patent, has just signed an unprecedented $240 million upfront deal with the pharmaceutical giant AstraZeneca to develop mRNA therapeutics.
Suddenly, hundreds of millions of dollars are flooding into the exact field she single-handedly pioneered. The technology she was told was a dead end is now the hottest commodity in biotech.
And what does she have to show for it? She is still sitting in a lab at UPenn, an under-recognized, demoted adjunct. The university sold her intellectual property, and despite the obvious commercial validation of her work, they still refused to reinstate her to a full faculty position.
It's worse than a lack of vision. It's just institutional arrogance.
It really forced a massive realization. She realized that the academic institution was fundamentally broken for her. If she stayed at the University of Pennsylvania, she would never get the resources or the respect to truly apply her mRNA expertise.
So she does what she has always done when a system tries to crush her. she pivots.
In 2013, she makes the incredibly difficult choice to leave academia entirely. She takes a job as a vice president at a relatively unknown, mid-sized German company called BioNTech RNA Pharmaceuticals.
Going from the perceived prestige of an Ivy League university, regardless of how terribly they treated her, to an obscure corporate biotech startup requires immense conviction.
But she knew the underlying science was bulletproof, and she was willing to move into the private sector to physically build the therapeutics she knew were possible.
And she grinds away there, largely out of the public eye, for several more years. The day-to-day reality of a biotech startup is grueling optimizing formulations, running endless preclinical assays, navigating regulatory hurdles.
But she excels. She's promoted to senior vice president of BioNTech in 2019. She is quietly, meticulously perfecting the science of mRNA delivery. And then, the calendar turns to late 2019.
A novel coronavirus, eventually named SARS-CoV-2, emerges. The transmission vectors are aggressive. It sweeps across the globe with terrifying speed.
Borders slam shut. Global supply chains disintegrate. Entire economies halt. The world is plunged into the most devastating and deadly pandemic in a century.
And suddenly, almost overnight, the entire planet is desperately, existentially dependent on exactly what Katalin Karikó has spent the last 30 years perfecting.
The speed of the scientific response was unprecedented, and it was entirely due to the foundational work Karikó and Weissman had laid.
When the genetic sequence of the SARS-CoV-2 virus was published online by researchers, the companies utilizing mRNA technology didn't need to cultivate live viruses in massive vats, which takes months. They pivoted immediately.
BioNTech, partnering with the pharmaceutical giant Pfizer, and Moderna, the company backed by the VC firm that tried to license her patent years ago, both utilized Karikó and Weissman's modified pseudouridine mRNA encapsulated in lipid nanoparticles.
They basically took the genetic code for the virus's spike protein, wrote it into the disguised mRNA instruction manual, packaged it in the fat bubble, and had a vaccine candidate designed over a single weekend.
Over a weekend. That's just nuts.
And when the clinical trials returned their phase 3 data, the medical community was stunned. The mRNA vaccines demonstrated over 90% efficacy in preventing symptomatic infection.
They were, without question, the most effective tools we possessed in curbing the global pandemic. To say that this specific technology saved millions of lives and prevented the total collapse of the global economy is not hyperbole. It is an objective statistical fact.
So, after 30 years of being told her work was useless, what did this global triumph mean for Katalin Karikó?
It means undeniable, absolute vindication. The woman who couldn't secure a basic NIH grant to save her career is suddenly hailed as the hero of the modern world.
And the irony is so thick you could choke on it. The University of Pennsylvania, the very institution that demoted her, denied her funding, and sold her IP, suddenly rushes to the forefront to publicly celebrate her and claim her as their own.
Of course they did.
Oh, yeah. The broader scientific media was ruthless in critiquing this hypocrisy. Major outlets, including the Wall Street Journal and the Chronicle of Higher Education, published scathing articles pointing out how aggressively UPenn promoted her success after the fact, conveniently glossing over their decades of systemic mistreatment.
It forced a very uncomfortable, very public reckoning within academia about how universities evaluate, value, and frequently exploit their researchers.
But outside of the university bureaucracy, the world did not hold back. The deluge of late-in-life recognition she received is nothing short of astounding.
Let's look at the sheer scale of the trophies. She wins the Lasker-DeBakey Clinical Medical Research Award, which is widely considered the American precursor to the Nobel. She's named Time Magazine's Hero of the Year in 2021. She wins the Tang Prize in Biopharmaceutical Science in 2022.
And then she reaches the absolute pinnacle of human scientific achievement.
The big one.
On October 2, 2023, the Nobel Assembly at the Karolinska Institute announced that the 2023 Nobel Prize in Physiology or Medicine was awarded jointly to Katalin Karikó and Drew Weissman
for their discoveries concerning nucleoside-based modifications that enabled the development of effective mRNA vaccines.
The highest honor on Earth. And even in the face of that, her reaction is so perfectly grounded.
What does she say?
During the frenzy of Nobel Week in 2023, she gave an interview where she flatly stated, "I dreamt about doing research, not getting an award." She continuously emphasized her lifelong, intrinsic dedication to the act of discovery over the extrinsic validation of recognition.
And she hasn't slowed down since Stockholm either. Her legacy continues to actively expand. Her actions following the Nobel are incredibly revealing of her character.
What does she do next?
Well, in April 2024, she took her entire portion of the Nobel Prize money, $500,000, and donated it completely to her alma mater, the University of Szeged in Hungary, where she now serves as a professor.
Wow. She invested the ultimate reward right back into the institution that fostered her initial curiosity.
Exactly. She also documented her journey. She released an autobiography right around the time she won the Nobel, titled Breaking Through: My Life in Science. It immediately became the best-selling nonfiction book in Hungary in 2023.
And it's won several awards since then, right?
Yeah, it won the Libri Literary Prize in 2024. And just recently, in May 2025, it won the prestigious Asimov Prize. The book has already been translated into over 9 languages, becoming a global manual for scientific resilience.
And her scientific standing is forever cemented among the elite. Also in May 2025, she was officially elected to the U.S. National Academy of Sciences.
And she delivered the Mendel Lecture at the European Society of Human Genetics annual meeting, where she discussed the vast, untapped clinical applications of mRNA therapeutics.
Because the COVID vaccines were truly just the proof of concept. The technology she fought for has massive potential applications in treating specific cancers, cardiovascular diseases, and complex metabolic disorders.
And perhaps the most telling detail of all, she even went back to Temple University in November 2024 to deliver a public lecture.
Temple, where Suhadolnik was.
Yes. She stood in front of the students at the exact institution where Suhadolnik had threatened to have her deported, and she told them the story of getting the early morning Nobel phone call. She used her platform to encourage the next generation to pursue research with persistence and enthusiasm.
That is a profound display of grace. She outlasted the system that tried to break her, not through bitterness or vengeance, but through undeniable world-altering competence.
Which brings us to the ultimate takeaway from this entire saga. Katalin Karikó's journey, from a house without running water in rural Hungary, to the suffocating paranoia of a communist police state, to the vicious, petty bureaucracy of the American academic system, and finally to the Nobel stage in Stockholm, is not just a triumph over complex biochemical hurdles.
It is a triumph over human bureaucracy. It is a massive victory over petty academic tyrants, highly risk-averse grant committees, and the staggering institutional blindness of elite universities.
It serves as a stark reminder that science is not conducted by sterile, purely logical robots operating in a vacuum.
Right. It is conducted by flawed humans operating within systems fraught with jealousy, politics, financial pressures, and deep systemic biases.
So I really want you to think about this the next time you are sitting at work. Whenever you feel like you are pushing a massive boulder up an impossibly steep hill, or when you are the only person in the room who believes in a project that everyone else is dismissing as a waste of time.
Remember Katalin Karikó?
Remember the woman who was demoted, mocked, threatened, and pushed to the absolute margins of her profession, who simply put her head down, ignored the consensus, and kept making photocopies until she literally changed the world.
She is basically the patron saint of stubborn persistence.
So as we wrap up this deep dive, I want to leave you with a final, slightly terrifying thought to mull over.
Okay, let's hear it.
We talked at the very beginning about how we want scientific progress to be a straight, clear, well-lit path. But the reality is incredibly murky. We now know, as an objective historical fact, that the current academic funding model actively and repeatedly punished Karikó for pursuing the exact technology that eventually saved millions of lives and stabilized the global economy.
It's true.
So ask yourself this: how many other world-changing, paradigm-shifting ideas are quietly dying right now, locked away in some demoted researcher's notebook, simply because they don't fit the rigid, risk-averse algorithm of safe science?
It is a chilling thought, and one that absolutely demands we rethink how we identify and support the minds trying to build our future.
It really does. Thank you for joining us on this deep dive. Keep questioning the consensus, and we'll see you next time.